Hello, students. In this session, we are going to look at circular motion kinematics. So first, talking about uniform circular motion. Here is a mass, and it is going around in a circular path like this. Since this is circular motion kinematics, we are only concerned about the initial velocity, let's call it omega initial, the final velocity, let's call it omega final, the acceleration, and of course the time. So we are not concerned about what is causing this motion. That would be dynamics of circular motion. So we are not concerned about the forces acting on it. What is uniform circular motion? Or what is uniform in uniform circular motion? Is it the velocity that is uniform? Is it the acceleration that is uniform? Or is it something else that is uniform? Let's take a look at that. Uniform circular motion is a motion where speed is uniform. Speed is uniform. Does that mean velocity is also uniform? Because velocity is speed and its direction. That combines to give us the physical quantity known as velocity. If we say that the speed always is 10 meter per second, here as well, here also 10 meter per second, here also it's 10 meter per second. Can you say that the velocity at these three places is also the same? The answer is no, because even though the speed or the magnitude of velocity is the same, its direction keeps on changing. So the velocity keeps on changing. So velocity is not uniform in uniform circular motion. One thing to note. What else is uniform? Is the acceleration uniform? The acceleration, since this thing is going around in circles, there must be a centripetal force helping this move around in circles. Because of that centripetal force, we are going to have a centripetal acceleration. So this centripetal acceleration can be written in terms of speed. So the magnitude of centripetal acceleration would simply be v squared upon r. Or if you want to write it in terms of angular velocity, you can write it omega square r, because all of us know that v is equal to omega r in this case. Okay. Actually, v is equal to omega cross r. V is a vector, but the magnitude would be here because the angle between omega and the angle between the radius is 90 degrees. The radius vector is 90 degrees. All right. So v equal to omega, we put that, we get this as the acceleration, the centripetal acceleration. So this thing is omega square r. When the object is at point A, the acceleration is directed this way. And what is the magnitude of this acceleration? It's omega square r. When the object is at point B, the magnitude of acceleration is still omega square r, but what is its direction? Is its direction the same or different? You would see that its direction is always pointing towards the center of the circle. So direction is changed now, right? Earlier the direction was this, now the direction is this. If the magnitude of acceleration is the same, but the direction has changed, can we say that the acceleration has also changed? Or can we say that the acceleration is constant or the acceleration is uniform? We can see since the direction is changing, acceleration is not uniform at all. So acceleration is not uniform. Okay. So again, in uniform circular motion, speed is uniform, velocity is not uniform, acceleration is not uniform. What else is uniform? How about this quantity omega? So this quantity omega, which is the angular velocity of this angular motion, of this circular motion, is given by d theta by dt, or it's the rate at which this theta is changing. This angle is changing. It's the rate at which this angle is changing. If This angle is changing very fast. That means this object is going very, very fast. The value of omega would be high. If this is going slowly, then the value of omega would be lower. So the rate of change of angular displacement, which is denoted by theta, is called angular velocity. Is this constant or is this variable? Well, in uniform circular motion, the magnitude of omega is definitely constant, okay? Because speed is constant, speed upon radius, that magnitude, that value is always constant. So we can say that, fine, omega's magnitude is constant. What can you say about the direction of omega? So omega's direction depends on the nature of rotation. If this is rotating anti-clockwise direction, you apply the right-hand thumb rule and you find the direction of omega. So the thumb gives you the direction of omega. So if you look at this circle and the object is moving from A to B to C, then omega would be pointing out of the plane. So if the object is moving from A to B, omega is pointing out of the plane. What if the object is moving from B to C? Again, same, out of the plane. So if the object is moving counterclockwise, anti-clockwise, omega is always pointing out of the plane. So the direction of omega is also constant. Magnitude is constant, direction is constant. So we can say the angular velocity, the entire vector, is uniform. Okay? So what is uniform in uniform circular motion? First thing, speed is uniform. Second thing, the angular velocity vector is uniform. Velocity vector is not uniform. Acceleration vector is not uniform. I hope this part is clear. Let's move on to apply this logic to a question that appeared in the last year's NEET exam. All right. So here you have a very straightforward question. It's saying there's a particle moving with uniform speed in a circular path. That means this is a uniform circular motion. Uniform speed, remember? Uniform circular motion. So what about it? So they're asking, what is constant in this uniform circular motion? We've already seen that speed is constant. Velocity is not constant. It's not constant. Acceleration is not constant. If they simply ask about the magnitude of acceleration, then we can say, okay, fine, that is constant. Magnitude of velocity, yes, that is constant. Magnitude of velocity is speed, we all know that. Velocity is not constant, acceleration is not constant. But we saw that angular velocity, this entire vector, is constant. So what can we say now? Which would be the answer? Constant velocity, no. Velocity is changing. Constant acceleration, no. In uniform circular motion, acceleration is not constant. Constant velocity, but varying acceleration? Well, varying acceleration, I agree. But constant velocity, no. Varying velocity, yes. Varying acceleration, yes. Hence, option 4 would be the correct option. Okay.